Okay, hello everyone. I welcomes to all in our lecture series on mathematical physics, that is your core paper 8, belongs to 4th semester B.sc physics on our syllabus CBCS model. Okay, in our last class we have been discussed Laurent series. Okay, in detail we have been discussed. We proved that one. Okay, in detail we have been proved here. This is the Laurent series of a function. In detail we have been proved the Laurent series. Okay, in our last class. In this class we are going to discuss few numericals based on basic numericals based on Laurent series. So before we are going to start the numerical based upon the Laurent series, first we are going to just revise what we have been discussed in our last class. Okay, so in this Laurent series we have been discussed that sometimes we need to find out the series around the singular point of the function. Okay, except the singular point, Taylor series is the series of that function, but around the singular point Laurent series we need to find out. So this is the Laurent series that we have been proved in the last class. And to how we have been proved, we consider that suppose a function fz, okay, z0, here this is the singular point of that function. We consider the two concentric circles, that is your c1 and c2. You can say this is your outer circle and this is your inner circle. In between these two circles, or you can say annular or shaded region, this one, in this region the function is analytic. At z0 it is not analytic, so the function is analytic on the c1, on the c2, and in between the region the function is analytic. This is the singular point of that function. So then we have been solved by using crosscut, by converting this one to the doubly connected region, and then we have been applied the Cauchy's integral formula, and we found this one, equation number 3 and equation number 4. f1z equal this one, f2z equal this one. So to evaluate the f1z, here f1z means this one, 1 by 2 pi I closed integral of c1 f z dash dz dash by z dash minus z. To evaluate that integral, what we done, here you can see this factor, that is 1 by z dash minus z, 1 by z dash minus z, written in this format, z dash minus z0 minus z minus z0. Why we have been written? Because we convert this one, this denominator, in the form of 1 minus something, and this something value is less than 1. So if it is so, then we can directly apply this one, 1 minus x, 1 by 1 minus x function is there, and its corresponding Taylor series we can write 1 plus x square and so on. So for that we have been converted this denominator with this one. So for that we considered z dash minus z as z dash minus z0 minus z minus z0. So here you can see, here this is your z minus z dash, here minus plus, so z0 got cancelled, and we can found z dash minus z. So to convert this one to this, for f1z, carefully watch, this is most important. For f1z, that means when we are dealing with circle c1, for this case we consider z dash minus z0 minus z minus z0. But when we are trying to find out f2z, at that time z minus z dash converted to z minus z0 minus z dash minus z0. Okay, so here in this case z dash minus z0 minus z minus z0, and here this will be z minus z0 minus z dash minus z0. Why I am telling these things? Because whenever you are going to solve the numerical, no, this one is most important, this expression, that means the denominator, how you are going to write in this format, that means in this format how you are going to write, at that time it will be required. Here you can see, one for f2z, this z minus z dash converted to this one. So here what we done here for this f1z case, for f1z case, here you can see z dash is on the circumference of c1, and on the c1 fz is analytic, and in this analysis also fz is analytic. We considered any point in this analysis, suppose z. Okay, so here z dash minus z is there. Z dash minus z means, suppose you consider this distance, I'm going to zoom somewhere, it will be better. So z dash minus z means this distance. So this distance is written as z dash minus z0. Z0 is your singular point. about which we are trying to find out the Lorentz series. So z0 is your singular point, z dash minus z0 minus here z minus z0. So this denominator z dash minus z is transformed to this format. Okay, so whenever you are moving out to in, see C1 is the outer point, you are moving inward, that means out to in. You are moving out to in, this tricks you just remember. When you are moving out to in, C1 is the point outside and you are moving the point which is inside the annulus. Okay, then you have to apply this one, z dash minus z0 minus z minus z0. Z dash is your outer point minus your singular point about which you are trying to find out the Lorentz series minus z minus z0. Got it? Then here, which one is the first term? This one is the first term, z dash minus z0, just take outside. Z dash minus z0 taken outside, and rest of the things will be 1 minus z minus z0 by z dash minus z0, and this term automatically it will be less than 1, and you have to just apply this one, 1 by 1 minus x form. Okay, now we are going to go for evaluation of f2z. Here you can see, at the time of evaluating f2z, what we done here, f2z, for f2z we considered what, C2, right? Here you can see, for f2 we have to consider C2. Okay, C2 means inner circle, and here we considered any point z in between the annulus, means here, and for this case z dash on this C2. So here we are moving z dash to z. For f1 case we are moving z dash to z, means out to in. Carefully you just watch this one, this out to in, and here for this case it will be in to out. In, z dash is inside, and z which is in the annulus is out with respect to this z dash. So if you are going to move z dash to z, that means it is what, into out case. So whenever you are going to move into out, then you have to use this one, z minus z0 minus z dash minus z0. Remember, always is the most important. When into out, z minus z0 minus z dash minus z0. When out to in, you are going to move at the time of numerical, it will be required. Okay, out to in, you have to write z dash minus z as z dash minus z0 minus z minus z0, right? Then we here for f2z we written z minus z dash as z minus z0 minus z dash minus z0. First term is this one, z minus z0, take common from these two terms, we found z minus z0 whole into 1 minus z dash minus z0 by z minus z0. This will be automatically less than 1. So this is in the form of 1 by 1 minus x. So 1 by 1 minus x, easily we can write 1 plus x square, like that the series will be. Okay, so to convert this 1 by z minus z0 in the form of this one, we done this one. For f2z means which case? This is your into out case. You just remember, you have to write z minus z0 minus z dash minus z0, and for out to in case, it will be z dash minus z0 minus z minus z0. Okay, now you just remember this one, it will help you to solve the numericals. Okay, now we are going to go for the numerical. Our first numerical is this one, that find Lorentz series of, here two bits are there. First bit question is your 1 by z, this is the function 1 by z about z equal to 0. Second question is your 1 by z minus 1 about z equal to 0. Clearly for this question and this question, z0 is your is the singular point of this function. For this function, z equal to 1 is the singular point. That means in this question it has been asked that we have to find out the Lorentz series of this function and this function about their singular points. Okay, first we are going to go for this first I, then second I. Okay, so before we are going to start these two numericals, again I am going to tell to you that you just remember that whenever you are moving from out to in case, the denominator will be right in this format. If you are going to write in this format, then it will be easy for you to find out its corresponding Lorentz series. For out to in, it will be z dash minus z0 minus z minus z0. For in to out, whenever you are going to move from in to out, then you have to write the denominator as z minus z0 minus z dash minus z0. We are going to do these numericals. From that you can clear how you are going to use out to in to out, This is the so-called one type of tricks, you can say itself. Okay, and here remember, z dash is the point from where you are moving, from here, where you starts your motion, from where you moved, you start to move. Okay, that may be external point, that may be internal point. And here z0 is the point about which you are trying to find out the Lorentz series. About the point, z0 is the point, is represents about the point you are trying to find out, you are trying to find out, trying to find Lorentz series. Okay, you just remember these two things. Okay, now we are going to solve first bit then second bit. Okay, here I am going to say one thing, that may you remember in our last class we have been discussed. First we have to find out, see, for a particular function, we need to find out f1z, and we need to find out f2z, then add, finally we have to just add f1z, f2z. Here you can see that f1z we found this value, so this is a series, and f2z we found this one. Okay, so finally the Lorentz series will be f1z this series, f2z this series. Okay, and this is called as your analytic part, this is called as your principal part. Here you can see, and in the analytic part, an z minus z0 to the power n. Here summation starts for principal part is your n equal to 1 to infinity bn z minus z0 to the power minus n. Okay, this is your principal part. In detail we have been discussed in the last class. Okay, so any Lorentz series given in the question, we need to find out this one, analytic part and principal part, then finally we have to add both, we can get the final answer. We are going to do so for this, for these questions. First we are going to go for the first bit. So to solve this question 1 by z, Lorentz series of 1 by z about z equal to 0, we have to locate its singular point in the complex plane. So first we have to draw the complex plane. Okay, this is your real axis, this is your imaginary axis. So here you can see fz is your 1 by z. So obviously z equal 0, it is a singular point. So z equal 0 means here, this is the point, is nothing but the singular point of this function. Singular point, that is your z equal to 0. Z equal to 0. In the question, it has been given that we have to find out Lorentz series about this point. About this point means about its singular points. So z equal to 0 will be equal to our z0. That means about the point we need to find out means the point itself will be treated as z0. Right? Now, as we discussed, just to find out the Lorentz series, we need to consider two circles, two concentric circles. So here, if it is the singular point, then we have to consider just above this circle, above this point, one circle. This is your inner circle, that is your C2. Okay, outer circle. See, one or two question you just do this way traditionally. Then whenever you are going to practice, you can do automatically. Okay, so outer circle is your C1. As we discussed that in this analysis, in between these two circles, in this analysis, the function is fully analytic. We are going to consider any point, any arbitrary point z, and z dash for this C1 on the surface of C1, and z dash will be here on the surface of C2 will be treated as z dash. Okay, and any point z, any point in the analysis will be considered as z point. Okay, okay, so here point on the circumference of circle, either C1 or C2 will be considered as z dash. This point is your z dash, this point is your z dash. Now we are going to find out f1z and f2z, right? First we are going to consider f1z. Okay, before that we have to write systematically first. So in the first bit we have to find out 1 by z. Okay, given function is your 1 by z, we have to find out Lorentz series about z equal to 0. That means this will be your z0, and this is your what, singular point, right? This is the singular point, and we know that Lorentz series, for the Lorentz series, in short I am writing ls. Okay, Lorentz series of any function fz is nothing but f1z plus f2z. So f1z we have to find out and f2z we have to find out, then we are going to add finally. First we have to write find f1z, finding of f1z. Okay, put a small heading, finding of f1z. So for the f1z we have to consider what? Consider c1. Okay, consider c1. So if I'm going to consider c1 and I'm going to move from this c1 to this point, that means what I'm doing, suppose you are here on this circumference of c1, on this circumference of c1 you are standing over here and you are trying to move to z, any point in this analysis. That means you are moving out to in, right? Out to in. So for this f1 we have to consider what? Out to in concept. Out to in concept. So out to in concept we have to consider. Now we consider here, for this case z0 is what? Z0 is 0. About z0 equal to 0 we need to find out the Lorentz series about this point. That means its corresponding singular point z0 is 0. Now what will be, okay, first see here, to write the denominator for this case, out to in, what we need? Z dash we need and z0 we need. Z is any arbitrary. So here z0 is your what? 0. What will be the z dash? You just think, what will be the z dash? Here we consider this one is the circle c1, but for this function, particular function 1 by z, only z equal to 0 is the singular point. Except z equal to 0, all the points here, any point will be analytic. That means this z dash can be taken here, can be taken here, can be taken here, or can be taken infinite itself, infinite. Okay, so this z dash can be at the infinite distance. So only for that z dash will be considered as infinite for this case. So now the function, given function 1 by z will be written as, to finding the f1z, 1 by z will be written as it is moving from out to in, this 1 by z will be written in this format. What? In this format, this one, z dash, whenever we are we discuss, no, z dash minus z0 out to in means z dash minus z0 minus z minus z0. So z dash minus z0 in generally first you write minus z minus z0, z minus z0. Okay, you just do step by step traditionally, 2-3 numerical, then after whenever you have the practice, you gain the practice, means you can do easily. Okay, so that implies here 1 by z will be equal to, carefully watch, okay, 1 by, here z dash means we have to put what? Infinite minus 0, sorry, infinite only, infinite minus 0, then minus z minus z0 is your 0. So here we can find 1 by, here you can see infinite minus something means what? Infinite itself, infinite, and we found the value is 0. So here we found, therefore what we found, f1z equal to 0. So f1z, this value we found 0. Now we are going to find out f2z. Okay, carefully write your note, most important. Then we have to find out the f2z. Find of f2z. So here you can see from the figure, whenever we are going to calculate f2z, that means we are going to consider c2. So suppose you just think you are on the circumference of this c2, that is your position is your z dash. You are trying to move to this z point which is inside this analysis. that means you are moving into out. Yes or no? You are moving into out. Okay. So to finding the F2Z, we have to consider what? C2. Consider C2. That means into out case. Into out case. Okay. So here, most important, remember, here Z dash will be how much? Just think. Z dash will be how much? Here C2 is the circle having the radius is tends to 0. Already we have been discussed in our last class whenever we are discussing the Lorentz series. So here this point is your a singular point. No, so to exclude this singular point, we consider this C1, what we discussed in our last class. So C2 radius is very small. Radius is very small. So if this radius of C2 is very small, then this Z dash will be lie nearer to this Z0. Yes or no? So if it is so, Z dash will be equal to 0. That is your singular point, which value is 0. So Z dash here in this case, Z dash will be 0, which is nothing but is your Z0, right? Now for this case, for into out case, the function will be written in this format: Z minus Z0 minus Z dash minus Z0. Okay. Likewise, we have to write for this case 1 by Z will be written in this format: what? 1 by Z minus Z0 minus Z dash minus Z0. Yes or no? Okay. Equal to 1 by Z is the arbitrary point. Z as such we have to write minus Z0 is your 0 minus Z dash. Z dash is your, here for this case it is 0 minus Z0 also 0. So finally we found 1 by Z, right? 1 by Z. So here we found at the F2Z we found 1 by Z. Finally, what will be the Lorentz series of this function about Z equal 0? That means about its corresponding singular point will be how much? F1Z plus F2Z. So অতএব Lorentz series of 1 by Z about Z equal 0 will be कितना होगा? That is your Fz, given function your Fz equal to 1 by Z will be equal to how much? F1Z plus F2Z. That implies Lorentz series of F1 by Z will be equal to F1Z we found 0 plus F2Z we found 1 by Z. So Lorentz series here, carefully you just watch. Lorentz series of 1 by Z will be equal to itself 1 by Z. Got it? So Lorentz series of 1 by Z itself will be 1 by Z. Now we are going to go for our second bit question, that is your find out the Lorentz series of 1 by Z minus 1 about its singular point. That means about Z equal to 1, because for this function Z equal to 1 is your singular point, because if I will put Z equal to 1 over here, this will be 1 by 0, not to be determined. Okay, so for this case singular point is your Z equal to 1, and as per the question we have to find out the Lorentz series about its singular point. Here in the first bit we proved one type, that Lorentz series of a function about its singular point is itself. So for this case, what will the Lorentz series of this one about its singular point Z equal 1 will be 1 by Z minus 1. That we are going to check. Okay. So second bit question is your finding the LS of, here LS means Lorentz series of 1 by Z minus 1 about Z equal to 1. That means it's about its singular point. Here, okay. To do that, first we have to locate this Z equal to 1 point in the complex plane. For that we have to draw the complex plane first. This is your real axis and this is your imaginary axis. This figure is most important. Any question belongs to Lorentz series, I suggest that you just draw the Lorentz series, this figure. Okay, I will do for all the questions whatever we are going to discuss. You just draw figure first. So here, suppose this is your 1 2 3 4 like this, and this is your minus 1 minus 2 minus 3 minus 4 like this. This will be along this way, I 2I 3I 4I minus I minus 2I like this. So for here Z equal to 1, that means this is the point about which we need to find out the Lorentz series. So here this point is your singular point. This is your singular point, or z equal to 1, and as we are going to find out the Lorentz series about this point also treated as or taken as z0. We know that about any point we want to find out the Taylor series or Lorentz series, that point will be considered as z0. So here z equal to 1 will be considered as z0. So before we are going to find out the Lorentz series, we know that the Lorentz series of any function is nothing but your f1z plus f2z. So for f1z we need a larger circle and f2z is a smaller circle. C2 is this one, and C1 is this one, and C2 is the very small circle which required to exclude this point. Exclude means to cut from this plane. Okay, to exclude this point. So about this point C2 we are going to draw, uh, and the radius of the C2 is very small. Okay, we are going to do so that one first. So first we are going to draw the C2. This is your C2. This is your C2 circle, and then we are going to draw the C1 circle. This point, about this point means this point will be the center always. Okay, about this point we drawn C2, and this is your larger circle is your C1. Got it? Larger circle is your C1. So inside these two circles, or in this analysis, the function is analytic. And here we are going to consider any point is your z dash. Here inside the analysis, any point, arbitrary point is your z. On this circumference also we are going to consider a point which is your z dash. Okay, the first part of our work is completed. Then we are going to go for finding the f1z and f2z. Okay, see, for these two questions I suggest to all of you that you just write the note perfectly. Then other questions may you just squeeze your note. So in detail how we done the first bit, second bit also we are going to write the same things. Okay, so what we have to write, 1 by z about z, this singular like this. So here we have to write 1 by z minus 1 is the function about z equal to 1. That means itself the z0 is the singular point of this function, about which we need to find out the Lorentz series. Same thing, we know that Lorentz series of any function, we know that LS of any function is your what, fz will be equal to f1z plus f2z. So we have to find out f1z, f2z separately, then we have to add finally. So first we have to find out the find of f1z. Here f1z means we are going to consider the C1 circle. So you just consider, suppose you are standing over here and you are trying to move from z dash from here to this point. That means you are moving what, out to in. So this is the case of out to in, O to I, out to in case. And for this case, for f1z, what will be the z dash and what will be the z0? Z0 is your 1 here. For this case, z0 is your 1 and z dash will be C. Here z0, here z dash can be any point. See, for this function, except z equal to 1, all the points at the singular, sorry, at all the points this function is analytic. So except z equal to 1, it could not be analytic, because z equal to 1 is the singular point for this function. So except z equal to 1, this function is analytic everywhere. So this z dash can be taken here. That means the C1 circle can be this much size or this much size, or radius of the C1 circle can be extended to what, up to infinite. So in general, z dash will be considered as the infinite. Got it? So z dash here will be considered as infinite. Now the given function will be written as, that means the denominator of the given function will be written as, for this case, out to in case, first we have to write the in general form. What, that will be written as in the form of z dash minus z0, because it is your out to in case. Just remember this two procedure, you can say, two tricks, you can say, whatever you can say, but you just remember these two things. It will be easy for you to solve any type of Lorentz series. So how to means 1 by z dash minus z0 minus z minus z0, z minus z0. So that implies 1 by z minus 1 will be equal to 1 by z dash will be how much? It will be infinite minus z0 is your 1 minus z minus z0 is 1. Here you can see infinite minus something will be infinite. So denominator is nothing but we can get the infinite value. 1 by infinite will be equal to 0. So f1z finally what we found? 0. Now we are going to go for to finding the f2z. Okay. So put a heading, small heading, find of f2z. Okay. Okay. So f2z means we are going to consider the C2 circle. C2 circle means inner circle. Inner circle means suppose you are on the circumference of your C2 and you are moving from here to here. That means in to out. So this is nothing but case of the in to out case. And for this case, first we have to identify which one will be the z dash and which one will be the z0, because in to out we need to write in this format. So for this case, in to out case, z dash will be how much and z0 will be how much. See, z0 is nothing but, see, z0 will be how much and z dash will be how much. That we are going to find out for this case. Carefully you have to watch. Here you can see z0 we know that is your 1. Okay, what will be the z dash value? Previously so many times we have been discussed that this circle is very close to this point. That means the radius of this circle C2 is tends to 0. If it is so, this z dash will be z0. You got my point? I'm going to show you. See, this is your C2 circle and here this is the z dash and this is your z0 point. Okay, so if this radius is very small and this is your circle C2, so if this radius is very small, then this z dash is going to coincide with this z0 or not. So for this case, z dash will be equal to z0. Z dash will be equal to z0 will be equal to how much? Also 1. So for this case, z dash will be 1 and z0 all. Z0 1 we know. Okay. Now we are going to write the function corresponding denominator in the form this one. So 1 by 1 minus z will be equal to, first we have to write in the general form, that is your z minus z0 minus z dash minus z0. This will be equal to z minus z0 is your 1 minus here z dash is your 1 minus z0 also will be 1. Finally we found 1 by z minus 1. So here we found f2z equal to z 1 by z minus 1. अतएव our required Lorentz series, required Lorentz series of 1 by 1 minus z will be equal to how much? f1z plus f2z. That implies Lorentz series of ls of 1 by 1 minus z will be equal to how much? This one, f1z we found 0 plus f2z we found 1 by z minus 1. Or we can write Lorentz series of 1 by, here I written z minus 1, okay, z minus 1. 1 by z minus 1 will be equal to 1 by z minus 1. Okay, so Lorentz series of the given function 1 by z minus 1 about its singular point z equal to 1 will be equal to itself 1 by z minus 1. Remember it is most important, required in the different numericals, because these two are the basics of the Lorentz series. In general we can write that ls of a function about its singular point will be itself. That is, suppose we are going to consider Lorentz series of 1 by z minus 3 about z equal to 3, the answer will be how much? Same, itself only, 1 by z minus 3. Okay. So here we are going to stop our today's class. In our next class, we are going to discuss this question. Question number 2 as your find Lorentz series of 1 by z into z minus 1 about z0 equal to 1. About this point, z0 equal to 1. Okay, thank you so much for watching this video. I suggest you just write down this note and ready for the next class. Thank you so much for watching. Thank you.